Sir, good afternoon, sir. Ashok, sir. Dr. Ashok, sir.
Yes, I'm ready. Should we start?
Hello, sir.
Sir.
Good afternoon, sir. Welcome to 12th session on
Yes.
recent trends on high performance computer and the future HPC by Dr. Ashok G. Matani, sir, an eminent retired professor, multidisciplinary expert. Even though his basic domain is mechanical engineering, he is very familiar in IoT and this high performance and artificial intelligence uh, technologies. I welcome Dr. Ashok Matani sir to start today's session. So thank you, sir. Thank you for your kind acceptance and attendance.
Yes.
Thank you, sir. Thank you so much.
Yes. Good afternoon to all of you. My topic for today's expert lecture, this session, is high performance computing technology trends and future. Now, of course, this training is going on HPC and all these parallel synonyms, but I will not go in definition part, but I will go on what is developments, what will be future, what are challenges, and how these companies, what are various global players, and how they are offering their services, and what is also it is relevant to cloud computing also. Now, this is also called supercomputing, but it is used to refer. There is slight difference between supercomputer and high performance computer that we go in next slides. Now, this refers to use of advanced computational techniques and technologies to tackle the complex and demanding computational problems that require significant processing power and data handling capabilities. These systems can perform large-scale simulations, mathematical computation, scientific modeling, data analytics, and AI tasks. Even these conventional desktop computers and workstations are not capable of computing or analyzing this large complex data at high speeds. Hence, this HPC enables advanced data analytics capabilities across industries, powering real-time process optimization, drug discovery, market forecasting, and others. Now, this high performance computing enables the development of high performance capabilities in high frequency trading, computer aided design, computational fluid dynamics, genomics based personalized medicine, speech and facial recognition, autonomous vehicles, deep learning, pattern recognition, seismic exploration, and seismic tomography. This This high performance computing is evolving in many ways, including edge computing, quantum computing, and generative AI. This edge computing, it is processes data near the source of data generation rather than in central data center. This reduces latency, enhances responsiveness, conserves bandwidth, is important for applications that need real-time processing and decision making. Then quantum computing. Nowadays, this is most popular words. Quantum computing, new developments are going on in which this quantum computing and semiconductors both are interrelated. This both are this becoming essential for each other. This quantum computing is so spreading its wings in computer and AI applications. This quantum computing solves the problem that are too difficult for current classical computers. This can be used to design new materials, drugs, and chemicals. It can solve large optimization problems. Then generative AI. This uses HPC to train and deploy deep learning models, just like autonomous vehicles use AI systems trained on large data sets for real world scenarios. Then deep learning. It uses HPC to accelerate machine learning training. This HPC system distribute the workload across multiple processors, significantly reducing the training time. Then exascale computing. This is new concept or new words in which this computer system's ability to perform a billion calculations per second. Imagine this power. In next the words you will be when you'll be listening and reading these words, probably you'll be surprised how this is means how vast its data processing speed is. This performance is measured in exaflops instead of flops. These flops are stand for floating point operations per second. When we are referring to performance of very powerful computers, especially supercomputers, these exaflops are used instead of just flops because this exa represent the much larger scale, signifying a quintillion, means 10 raised to 18, 10 to power 18. Imagine what is this the multiplication if you go through this quintillion, these floating point operations per second, making it a more appropriate unit for measuring extremely high computational power. Essentially, exaflop is billion flops. This key points about exaflops, that is exa is metric prefix meaning a quintillion, that is 10 raised to 18. This and the use cases are exaflop is primarily used to measure the performance of high-end computers, supercomputers used for complex scientific simulations and AI tasks. Then this GPI computing, this graphics processing units to perform data intensive work. This includes machine learning and self-driving cars. Then cloud computing. Of course, this offers scalability and flexibility in high performance computing. I will cover. Yesterday we were unable to cover this because of some network issue, but I have added some of the contents which are related with cloud computing in this session also, so that we can compensate this, that is whatever we have lost that because of this network issue. It is now resolved today. Computing is the process of calculating or simulating real world scenarios with the use of supercomputer. And supercomputer consists of tens of thousands of processors, all of which work together to complete large and complex tasks that will be too difficult, costly, or time intensive to perform in the real world. These supercomputers are used for a wide range of simulations in variety of different fields, including weather forecasting, molecular dynamics, physical simulation, as well as other industries. These large academic and government funded organizations often build supercomputers to conduct large scale research projects. These supercomputers require significant upfront investment in components and facilities, expertise in IT and facilities, and time spent on implementation and ongoing maintenance. This high performance computing is the broad term that includes supercomputers, but typically refer to use of aggregated high performance computer as service servers clusters that contains specialized components. It is often used to tackle the same kinds of computational problems as supercomputing. However, HPC is more commonly used and it can be carried on engineers' workstation. Different industries, technology providers are developing new tools to meet these growing HPC needs of engineers, scientists, and researchers. This recent proliferation of specialized software hardware is driving business to diverse device strategies to simplify complex technology stacks and maximize their efficiency. Now, today businesses choose HPC approach because it can be purpose built and right sized to the needs of the business. Whereas supercomputers are typically feature static architecture, significant investment, and long time horizons. This now cloud HPC and HPC as a service offering have lowered the barriers to entry of organizations to deploy advanced computing operations where they were previously too complex and too cost prohibitive solutions. Having increased access to more computational engineering resources enables business to accelerate their R&D projects and even meet budgetary goals.
Sir, please unmute, sir. Please unmute.
Now, this HPC software market is estimated at US dollar 10.75 billion, and it is expected to reach 107.58 billion dollars by 2030 at the compounded average growth rate of 58.52. Means imagine what is the potential of HPC software market. This is global high performance computing market. This is projections are there. So, different areas are also there. Actually, after COVID, this HPC market or this potential have increased when in March 2020 when COVID was at its peak throughout world, and because of this has also turned new opportunities for computational resources in epidemiological modeling, genomics, biomedical research, and drug discovery. Now, in studying large data sets simulating complex biological processes related to coronavirus, HPC has played an important role. Then, impact of generative AI. These cutting-edge capabilities of generative AI for high-quality training data fueled market growth. This generative AI is at the forefront of realizing this high-performance computing, offering profound impact on algorithm development, quantum machine learning, and GPUs. This generative AI is capable to create complex and massive data adds in simulating real-world applications and ensure that HPCs are the ideal for several scenarios. Into January 2024, this adaptive enterprise computing launched Adaptive AI as a service offering that enables small and medium-sized business. This solution consists of end-to-end platform for developing AI and ML using powerful management software. Now, this is high-performance computing market trends and how this is going on. In which this blue color you are finding that 30% it is coming to government and defense sector. 30%, and these are different sectors in which all these health care and life sciences, then BFSI, manufacturing, energy, utilities, transportation, government, defense, media and entertainment, education, and others, retail also. This is US, especially for US high performance computing market share. So here again, this is also. Now this is global high performance computing for life sciences market research report. This one research study I have taken that data in which they have done this research on life sciences market research report, and they have declared and they have conducted these data throughout world in different parts of the world. So here we are finding this different component type and application type, drug discovery and development, genomic analysis, proteomics. So this is, and now this top 10 technologies trends to watch in 2025 and beyond, because now we are finding these new technologies going on in 5G. We are still yet to arrive at the last ultimum customer or stakeholder in remote rural areas in India. And the declaration of mobile 6G is officially declared by Honorable Minister Sri Vaishnav sir, and by the end of this year, our scientists and engineers will be announcing, or before that, this 6G technology will be coming in India. We will be throughout the world. It will be India, which is means working on 6G technology. Means so technology, so revolution is going on in every aspect of IoT and ML applications. We cannot imagine what quantum it takes or what speed it takes. Every time, every day, we are listening, seeing new developments where we cannot imagine how it is possible. But like considering their report, their results, it proves that yes, it is happening there. So quantum and so huge developments are going on. In this artificial intelligence automation, this is generative AI, hyper automation and predictive maintenance. It is advanced connectivity, this IoT, 5G and 6G, zero trust security, then sustainability, renewables and climate tech, biotech and healthcare, preventive maintenance, gene editing and synthetic biology, advanced engineering and robotics, advanced robots, autonomous vehicles, unmanned vehicles, what we are calling this. Tesla is also manufacturing these autonomous vehicles, but in India we will not be using at present. After 2 years, this will be introduced in India, autonomous vehicles, driverless cars, what we call that. But these are successfully working in US. Even when Honorable our PM Sir has visited US, one of the press correspondent, he was demonstrating, he was sitting in this Tesla car and he was showing that picture or scene, how these autonomous vehicles are running. And these are successfully means functioning in the US market. Then advanced computing, this edge computing and distributed cloud, quantum computing and neuromorphic computing. Then decentralized and digital trust technologies, this blockchain and decentralized finance. Then material science, nanotechnology, biomaterials and metamaterials. Then immersive technologies and human machine intervention, in which now cobots are also used, means now human and robots are working jointly together. This extended reality, virtual reality, this voice use interface, then brain computer interfaces, then space tech, in tech, space exploration and space tourism. Nowadays the space tourism is also going on in the US, because some people, they are now planning to purchase their flats and homes in Mars, what we call that Mangalyaan. They will be settling on Mangal Grah, this Mars. Means space tourism is also getting new means avenue nowadays. In America, these people, they are booking their flights in Mars, because some evidence of life at Mars is there. Hence, they are booking. Even in America, this flight booking on Mars is going on. Then, what are these top 10 high performance computing companies throughout world? Some of these are means nearly 60% of these are functioning in India, and you might have gone through names of these, or you are also using these companies' products at present in your day-to-day life or in your organization. This is HP, that is Hewlett Packard Enterprise Development LP, then Dell Incorporation. This laptop and computers, they are making Dell, that is very popular laptops, Dell company. Atos SE, Microsoft Corporation, Nvidia Corporation, IBM, Intel Corporation, PUC Limited, Cisco Limited, Lenovo Group. Lenovo is also, Lenovo of course it is Chinese company. Then Advanced Micro Devices, AMD Devices and NEC. This is the oldest company since 1938, established in Japan, NEC Corporation. These are key players in market, global market for high performance computing. This different operating system for HPC, that is CentOS, is widely used in data centers throughout the world and is for the most popular operating system for HPC clusters. This is some other RHEL and CentOS are the most widely supported Unix compatible operating systems in commercial scientific software vendors. And what is the fastest HPC in India? India is also made this supercomputer Airavat and Param Siddhi. These AI are currently these Param Siddhi AI. It is that version. These are currently the fastest supercomputers in India. Airavat is ranked 75th in the world as of June 2023. This is the image of this Airavat. Then which language is used in HPC? This each supports C, C++ and Fortran. Even there are most commonly used languages for HPC, that is also Java, Python and many other programming platforms. Even HPC also offers robust set of parallel programming libraries including OpenMPI and MVA PICS2. Then what is difference between AI and HPC? HPC is hardware, AI is software. Now this some of the different companies are industries where these HPC is offering are giving the most benefit, are most popular in this. First one is the finance sector or banks, what we call that, finance, share market and banks. These being able to make accurate predictions based on available data. Increasing number of hedge funds are moving towards data analysis to dictate what they should buy and sell. With how quickly the stock market changes, this wouldn't be possible without ability to quickly process huge funds data. Engineering firms, R&D engineering sections running computer simulations to test designs without having to build anything is vital tool for engineering company. This HPC greatly decreases the amount of time simulations need, allowing engineers to get designs finished and into production sooner. Different other sectors include scientific research, manufacturing, data mining, weather and atmospheric research, and oil and gas companies exploration. These are some of the examples. So this will be impossible for American Express to monitor their 110 million AMX cards without the deployment of machine learning algorithms. Thanks to AI, they are able to identify and block fraud in real time, saving themselves and their customers millions of dollars. At the start of 2020, means 5 years back, researchers from Imperial College London and Google revealed they have built an AI capable of outperforming human doctors in diagnosing breast cancer. Not only does this show us how advanced these technologies are, but it is an excellent example of how proper deployment of AI and HPC is going to literally save people's life. This HPC AI is capable of processing much information. It needs to run on sophisticated hardware which is capable of performing trillions of calculations per second. This is where HPC and AI intersect, since HPC uses their dense computer clusters and run these most advanced AI algorithms. Now this cloud computing and HPC. This cloud computing is designed for general purpose computing, whereas HPC is focused on high speed computing for complex problems, specialized problems. This cloud computing is a model of delivering computing services over the internet where resources such as servers, storage, database, software and applications are provided as a service to users on demand. This approach allows users to access scalable and on-demand computing resources without the need for upfront capital expenditure or maintenance. Scalability: cloud computing resources can be scaled up or down to match the changing business needs. On-demand access also, users can access cloud computing from anywhere at any time as long as they have an internet connection. Cost effective also. For cloud computing, this eliminates the need for upfront capital expenditure, and this also reduces maintenance costs. This multi-tenancy, these cloud computing resources are shared among multiple users, making it a cost-effective and efficient solution. Then in HPC, these are designed to perform complex calculations. Speed is designed to perform calculations at extremely high speeds. We have seen that. Specialized hardware is also required for this. Complex calculations are possible with the help of this, and customization is also. Then key difference, that is we have seen this cloud computing designed for general purpose, HPC is for high performance computing. Then these are 12 top global high performance companies at world level. First one is the Hewlett Packard Enterprises Development. It is having its headquarters at Palo Alto, California. This company, also known as HP, probably your computers in your computer lab might be of this HP company, I think, because in majority of the colleges or universities, these HP companies computers are used in computer labs. This HP offers software as a service and cloud computing solutions and software services like consulting, training, professional service and support. It also provides hardware, software and related services to individuals in small and medium-sized business, major RA and clients in public sector, healthcare and educational system. Dell Incorporation, it is most popular for laptops. Maximum number of laptops used are of Dell company. Those who are software engineers, they are using this Dell laptops. It is so most reliable company among software engineers. This Dell is an American internet technology company with its main office in Texas. This large variety of consumers and commercial gadgets are produced by Dell, including personal computers, TVs, servers, smartphones, corporate software, network, and information security. These companies expanding high-performance computing portfolio, providing strong solutions to assist business in quickly and confidentially innovating. This Atos SE, it is world leader in digital transformation. So this company is having 70, it's means tentacles in 71 countries, operating in 71 countries. This company provides information technology for games as well as cloud solutions, integrated system and software and cyber security. Then Microsoft Corporation. This is the largest developer of PC computer software and applications because whenever we are purchasing, majority of this we are using Microsoft Word and others. In addition to search and gaming, it is top supplier of internet service like computer hardware, video games, cloud computing, and others. Even most popular it is Microsoft Azure. High performance computing offers complete set of computing, networking, and storage capabilities together with workload orchestration. Azure offers comparable price performance compared to on-premises choices. NVIDIA, it is also one of these US-based company. It is having offices in Pune and Noida in India. It is headquartered in Santa Clara, California. It is known for producing IC integrated circuits, which is used from personal computers to gaming consoles. This is leading producer of advanced GPUs. This NVIDIA has expanded this high performance computing and AI. Then IBM Corporation. These are also popular in our colleges and this IBM company. Even this IBM company is visiting majority of the campuses for software engineers in universities and colleges. This company services include data analytics, cloud computing, and hardware and software for computers. This IBM Power Storage offers market leading independently. The offerings for AI include AI and machine learning, asset management, analytics, compute and servers, business automation, database and DevOps and networks. Then Intel Corporation. It is market leader in developing technology that transform world and improves people's lives. Even advent of intelligent age, this transition of 5G networks and AI are three major technological turning points. With the help of this new HP technology, processors and materials designed by Intel, quantum computing is moving from research to business worlds. Then Fujitsu Limited, Tokyo, Japan. It is in Japan. This is market leader in IT service. It has years of experience in developing IT systems, service, and digital solutions for public and private sector clients. This company constructs entire IT solutions for hybrid cloud environments by integrating its own servers and storage technology with networking and software products. Then Cisco. This is multinational company based in US, specializes in networking hardware, telecommunications, equipment, software, and other high-tech products and service. With its cutting-edge HPC solution, Cisco is able to satisfy the expanding computing requirements of market data feed handlers and other trading floor applications. Then Lenovo Group, it is in Beijing, China. This is one of the leading personal technology firms. Lenovo computers, Lenovo laptops are also popular. With this goal of bringing exascale level computing to business to also Lenovo, a world leader in high performance computing, collaborates closely with other top market players. Then AMD, this advanced micro devices. AMD, this is specialized in making semiconductors for use in computer processing. This company also produces flash memory, graphics processors, motherboard chipsets, and variety of other components for consumer electronics items. This AMD EPYC, of course, this is trademark. Then NEC Corporation Tokyo, this is the oldest company in supercomputing and computing. This NEC Corporation offers system component devices and integrated solutions. This offers the best HPC solutions based on highly developed expertise. This NEC is committed sales and pre-sales team with extensive expertise and internal development team or NUTC. Now this we have seen that. Now these top 10 high performance computing trends. Previously we have seen 10 technology trends. Now in that now top 10 high performance computing trends. This is AI, cloud computing, simulation and digital twins, scalable computing, edge computing, blockchains, cyber security and thermal management. So these are this is the one research it is published in which these top 10 high performance computing companies, and these are the top 10 companies, and this is the research work which is conducted on 549 startups and emerging companies analyzed, and out of these 10 top companies which are world leader in specific domain. So on left side we are finding this, and on right side we are finding these different their domains or areas and who are the market leaders in that. Means there in left side we are finding these are two companies, means in each domain two companies are means this is their product also. To this area is AI, cloud computing, simulation, digital twin and edge computing. And in that on right side this is names of these companies also who are market leader in this. And this is the impact of, after this results research which is published. This impact of top 10 high performance computing trends in which AI is having 30% impact. Cloud computing is 14%, simulation digital twins 13%, edge computing 7%, blockchain 6%, scalable computing 13%, quantum computing 6%, cyber security 3%, distributed computing 5%, and thermal management 3%. Now, this is this breakup of which have been studied, global startup heat map, high performance computing, in which these different parts of the world they have collected this data. Now, this top high performance computing trends. First one is AI. This AI algorithms optimize the performance of HPC system by enabling to learn from data and make accurate predictions to improve their efficiency. These AI-powered algorithms train on data from HPC systems to identify patterns and trends to optimize resource allocation. This AI enables the development of new algorithm software for HPC system that is specialized in solving complex problems. So this is one case study or name of that company, how they are offering this in related to this company, HPC and AI. This HPC AI technology accelerates deep learning model training. This is Singapore startup, HPC AI technology, it is name of that company. This develops a cloud-based software platform for model development using high-performance computing. This platform contains features of efficient memory management and dynamic scheduling, as well as supports data pipeline sequence and tensor parallelism. Besides this, it distributes training and interface of large neural networks. These startups AI-based open source code enables companies to integrate HPC to significantly lower cost in applications like medical research and financial forecasting. Then another company, Seromorphic, enables energy efficient AI supercomputing. This is US-based startup. Seromorphic manufactures ultra low power supercomputing chips to address HPC requirements. This startup processor contains proprietary multi-thread processing, thread arc, with quantum resistant security and uses 5 nanometer production process. It reduces the growing energy consumption in applications such as AI model training, drug discovery, metaverse processing, and more. Then second is cloud computing. These high performance computing services are expensive and require additional infrastructure. This makes HPC infrastructure expensive and inaccessible. This cloud computing overcomes this and provides business access to wide range of computing. These HPC solutions available on demand include processor, memory, and storage. It also provides easy access to otherwise inaccessible specialized resources such as flagship GPUs, quantum processors, and other specialized hardware. This is name of that and how it is providing this cloud service. This Nebula Cloud advances intelligent cloud computing. This is US based Turner startup, Nebula Cloud, name of that company. It develops a fully managed HPC platform to automate and optimize engineering workloads. These platforms feature include multi-cloud optimization, enhanced monitoring, automatic scaling, zero trust security, and advanced orchestration. This enables developers and engineers to deploy scalable, reliable, and highly available environments for end-to-end applications. It is another case study that is Tingyu. It provides low latency container services. This Tungyo is a Chinese startup that specializes in edge and cloud-based high-performance computing for low latency applications. This company's low latency edge container as a service solution is built on massive edge computing nodes and provides common container capabilities such as orchestration and deployment. It features electricity through hour-long use and billing with real-time monitoring. This solution allows video distribution services to leverage low latency via broadcast and on-demand capabilities. Then simulation and digital twins. This one of the biggest problems with digital twins is the complexity in scale-up simulations and models. They are also complex and data intensive and need significant computations to run. This high performance computing solves this problem by providing powerful and efficient computer sources that support demanding workloads. These HPC systems provide this computational power to model factories and supply chains to create production process within single virtual environment. This is the case study in which Collimator specializes in cloud-based simulation. This is US-based startup, Collimator. It makes modeling and simulation software using cloud-based high-performance computing. This software allows engineers to perform simulations in the cloud without provisioning HPC servers. It also runs large-scale simulations like Monte Carlo simulation, MILC and HIL testing and parameter optimization as well supports multiple situations simulations. This software allows design engineers to perform end-to-end testing and validation at massive scales. Then this is a case study in that. Boson Q PSI, this creates quantum computing powered simulations. This is Indian startup. It creates BQ PHY modeling software that uses quantum computing and multi-physics simulations. This quantum powered engineering simulation software lets engineers conduct design exploration studies. It computes and models deformations, stress and strains in solid materials and temperature variations per heat transfer cases. This modeling software enables engineering teams to perform acoustic, electrochemical, fluid analysis with accurate digital twins. Then scalable computing. This scalability is essential in high-performance computing, and this is case study in which control what we call that CTRL IQ. It manages massive cluster computers. This CTRL IQ is US-based startup that develops WearWop, a platform that combines hyper scalability clouds and HPC management and simplifies the process of acquiring, securing, and deploying resources from small researchers. This WearWop is able to scale up and down to easy deploy, administer, debug, and secure any clustering environment. Then this cluster power, it is Romanian startup specializes in scalable and reliable computing and data. This cluster power computing enables compute intensive processes, analytics, and large scale application programs. Cluster power cloud is scalable, secure, enterprise grade network file systems. It assists in heavy workloads with data management, high power data common data management. Like a bit increases network latency, the risk of data theft, cybersecurity we are finding nowadays. This This edge computing now brings computation closer to data sources, allowing HPC systems to process data locally. This enables healthcare organizations to develop new treatments and therapies and improve medical diagnostics without sending patient data outside hospital. This is a case study in which this Cornell's network advances emergency responder communication. This US-based startup Cornelius Networks, it creates high-performance fabrics that accelerate computing workloads. This OmniPath Express Edge switch, it uses an Open Fabrics interface framework that delivers super low latency and high message rates with ultra lower CPU utilization. It also ensures high network efficiency and security. Then this Permas, this is Tasmanian startup. It makes Cube 300. It is sustainable and scalable immersion cool data platform. It utilizes NVIDIA's deep learning GPUs and AI network fabric to provide sustainable low-cost computational cloud. This platform also retrofits to upgrade existing core and shell spaces. It hosts up to 130 kW per 42 RU with full stack metal orchestration through its super cloud, enabling various edge computing uses. Then blockchains. These blockchain networks rely on distributed network of computers. These blockchains with higher transactions also stress networks, limiting their ability to support high volumes. So this is case study in which this Inspire Semiconductor, this is US-based firm. It specializes in developing high-performance computing, AI, and blockchain accelerators. This startup's supercomputer cluster on a chip accelerator architecture, Thunderbird, name of that, features an array of thousands of efficient and powerful 64-bit CPU cores. These are tightly integrated with high-speed memory and networking. Then this is also another case, Kudos. It is UK-based startup that provides blockchain platform using decentralized cloud computing network. Its layer 1 network, Kudos network, offers scalable distributed computing direct to small contracts. This Kudos other product, Kudos Bridge, support the migration of bridge, bringing up holdings between Ethereum and startups blockchains. Through these solutions, Kudos enables net development in the metaverse, dynamic non-fungible tokens, NFTs, decentralized finance, and more. Then quantum computing. This is pointing the means hotcake of today in IT applications are revolution. It is now quantum computing. So huge developments and enormous potential in this quantum computing. You might have seen this when you applied for training programs on ATAL FDP. Maximum number of trainings are offered on this quantum computing title. It is having so huge potential in IT and IoT applications. These quantum computers use quantum bits or qubits instead of classical bits to represent and manipulate data. This makes building and maintain quantum computers challenging as qubits are fragile and easily disrupted. These HPC systems are able to develop and test new algorithms and applications for quantum computers and simulate and analyze the behavior of quantum systems. These advances in computer further enable HPC systems to solve various issues. This is one case study in which this QMware provides a hybrid quantum cloud. This is a Swiss startup, QMware. This creates hybrid quantum computing systems for private clouds. This startup simulator allows business and developers to test hypotheses, ideas, and algorithms and run providers interface and software support for running codes. It serves as a benchmark tool and estimate the effectiveness of current HPC devices. Then this is Nord Quantic develops error correcting quantum processors. This Nord Quantic is a Canadian startup that develops error correcting quantum processors to mitigate errors on individual qubits. This startup implements bosonic codes with superconducting circuits to provide richer encoding spaces. These startup superconducting circuits provide complete toolbox for engineering high-performance bosonic codes while addressing the issue of noise on chips. Then distributed computing. These supercomputers and hypercomputing this system power resource-intensive applications such as DNA modeling, video rendering, AI development, and this. To handle these tasks, HPC data centers need high capital and operating costs to build and maintain such HPC systems. This distributed computing solves the cost and reliability challenge by connecting computers through the internet to pool their computing resources. This distributed computing improves load balancing and fault tolerance as well as enables decentralized computing. This is a case study in which this how this is offering their service. This Canadian startup Flux Network, it offers distributed cloud-based supercomputing. This makes a distributed cloud-based supercomputing system that uses peer-to-peer networking. This startup solution Flux ecosystem allows users to connect their smartphones, tablets, laptops, and gaming systems to its network and pools access processing power. This Flux solution also utilizes machine learning to optimize computing resources and divide tasks among users. This Flux network encourages users to join and build large resource pools by providing monetary incentives. Then this is another case in which LongDB technology is specialized in hybrid transaction and analytical processing. This is Chinese startup. LongDB technology develops an enterprise data platform that integrates a distributed hybrid transaction and analytical processing HTAP engine. So this intelligently determines access paths, execution strategies, and parallel algorithms. Then cybersecurity. Of course, this is the most challenging task nowadays. Cyber criminals are so active nowadays. Even most literate person in computer and IT, those who are masters of computer and IT, they are also becoming the victims of these cyber criminals, cyber attackers. Hence, these cyber security skills are most demanded in today. This rising volume and complexity of cyber threats such as malware and ransomware increase the interest in cybersecurity across industries. These threats have significant impact on security and integrity. This HPC alleviates this problem by providing powerful and efficient computing resources that support the research and development of cybersecurity solutions. These HPC systems enable security companies to develop and test new algorithm technologies for detecting and preventing these cyber threats. They also analyze a large volume of data to identify patterns and trends that indicate the presence of cyber threats. This is case study. Petero offers a hybrid post-quantum crypto module. This is Petero is US-based startup that develops a software-based crypto module that combines traditional and quantum registered algorithm to protect critical communications. It features enhanced compliance and security by using certified algorithms and NIST qualified post-quantum candidates. The software is easy deployable in various systems, including bare metal, cloud, and edge environments. This Petero's cryptographic cybersecurity solution enables telecom providers to protect their customer data and banks to secure digital transactions. This Quant LR, it is Israeli startup. It delivers quantum encryption. This is specialized in quantum cryptography-based cybersecurity. This startup's plug-and-play quantum cryptography solution uses existing hardware components to reduce cost and enable mass deployment. It also securely transfers keys in network, detects and prevents and negates the man-in-the-middle attacks. Then thermal management, of course. These modern CPU and GPUs are capable of processing enormous workplace in real time, but they also require immense power and cooling. Air cooling requires multiple high-speed and loud fans, while water cooling requires extensive hardware modifications. For these reasons, startups are developing cooling technologies such as immersion cooling and MEMS-based cooling pads. These make cooling high-performance computers simple and effective, as well as mitigate in-house product development. Now, this is the case Ripford. It is an Indian company. It avances immersion cooling. This Ripford provides immersion cooling solutions for mission-critical computing applications. These products include immersion cooler that dissipates up to 50 kilowatt of heat, EcoPet24, and another cooler with up to 200 kW heat dissipation in 42U format EcoPet42. This Ripford provides plug-and-play rapidly deployed solutions in a box office for high-premise data centers. Then This Corintis develops silicon microfluidic cooling. This is Swiss company. Corintis, it makes a silicon microfluidic cooling solution that enables very low operating temperature in high density and vertically integrated circuit designs. This technology features a monolithic three-dimensional network of microscopic channels. To these channels support 2000 WSCM of heat extraction, extremely low pressure drop and reduced coolant consumption. This Corintis solution avoids inefficiency of heat transfer due to multiple layers in traditional or liquid cooled systems, because these semiconductor chips or this quantum computing infrastructure or high performance computing infrastructure, these requires cryogenic conditions of air conditioning. And hence, whenever these computers are working, some heat dissipation is there, and these should be easily managed. Otherwise, this, if the temperature is not managed, then probably their function will be disturbed. And this is the problem of semiconductor chips. If noise problem is there, or vibrations are there, or temperature is more, then probably the function of the semiconductor chips will be disturbed. That is the main drawback of these latest chips. Hence, thermal management it is playing important role in computer systems. Then I will show 5 minutes video in which what is going on at world level we see. One minute, I'm sharing that. Yes, it is seen to you, all of you.
I'm pleased to introduce the speaker for this session, Britt Banerjee, Electronic Design Automation. We're
about the use of AI ML, HPC and AI machine
Well, the
learning.
audio is visible, sir. Audio is coming, sir.
So let's begin. But before
Voice and audio both are video audio both are compatible?
Audio is okay. Video film is
No.
clip is only showing.
Yes, sir. I will now play. Just I am confirming whether it is working or not.
I begin, I want to kind of
Now,
briefly introduce myself.
okay.
As I said, I am CTO at ANSYS
Voice is coming.
about
Video is not coming.
4 years.
Playing.
Previous to
1 minute.
ANSYS
Folders are visible. Folders are visible.
in academia as a professor, our long-term,
Now it is coming.
and then go
No, sir, no.
deep into the discussion of AI/ML and high-performance computing. And
1 minute, I am sharing that again. Now
so
it will come.
ANSYS has been using the power of
Now it is there?
simulation to help customers
Yes, sir. Yes,
build
sir.
amazing products
Yes.
in different
We go as
markets.
it is now.
For example, we work with Airbus in the aerospace and defense area. We work with customers such as Magna as a tier 1 supplier in the automotive area. We work with Medtronic and Boston Scientific in the healthcare area. We work with LG in the high-tech area, and we work with customers such as Schneider Electric in the energy area. In terms of partnerships, we have very strong partnerships with a lot of companies, including Rescale. Thank you, Rescale, for inviting me to speak today at the Big Compute Conference. But we are partners with all the chip companies such as Intel, AMD, and NVIDIA. We are partnered with all the cloud companies, such as Microsoft Azure and AWS, and customer and partners such as Autodesk and Synopsys. So this talks about a very broad overview of our ANSYS product portfolio. The bottom of the pyramid, you can see our core solvers such as structural analysis using finite element analysis for mechanicals, the ANSYS Mechanical or LS Dyna. Fluid simulation products such as Fluent using finite volume methods, electromagnetic simulation such as Maxwell for low frequency or HFSS for high frequency, semiconductor simulation or power integrity such as Red Hawk SC, optical simulation, photonic simulation, and so on. So those are the core physics simulations that we have to offer with our customers. Then on top of those physics simulation, we have software simulation capabilities using tools such as SCADE for embedded software and Matani for safety analysis and Twin Builder for digital twins. And then we have a platform using sort of materials platforms for materials, optimization platforms such as OptiSlang, and we do all of these multi-physics simulations on top leveraging HPC on the cloud. We take our simulation solvers and we have built out entire solutions for autonomy, electrification, 5G, and industrial Internet of Things. And we serve more than 40,000 customers in the verticals of aerospace and defense, automotive, energy, healthcare, and high-tech. So as CTO at ANSYS, I am responsible for setting our long-term technology strategy. And 12 pillars that I have mentioned here, pillars such as numerical methods, where we're looking at more accurate, faster, easy to use, and robust solvers, looking at newer methods for meshing and geometry, the use of AI, ML applied to simulation, high performance computing, leveraging different forms of parallelism, new ways of doing user interface and visualization, different types of platforms, use of the cloud. We have an entire work on developer ecosystem and solutions, model-based systems engineering, digital twins, integrated ICME and sustainability.
అకాడమిక్ రెండు పెట్టు అకాడమిక్ రెండు పెట్టు మిగతా వాళ్ళకి ఒక సింగిల్ పెట్టు అకాడమిక్ రెండు ఉంటాయి మిగతా వాళ్ళు ఓన్లీ ఎక్స్పీరియన్స్ ఉంటుంది ఇండస్ట్రీ ప్రొఫైల్స్ ఉన్నాయి ప్రొఫైల్స్ హార్డ్ కాపీస్ అవి పీపీటీలు ఎంబీ లోపల ఉంటే కనుక అవి పీపీటీ డౌన్లోడ్ చేయి అది కదా పీపీటీలో అంటే నేను అందులో అప్లోడ్ చేసుకుంటాను నీకు మీరు పేరు పెట్టి కాకుండా అవి నాకు పెట్టారన్నా కదా నా మెయిల్ ఓపెన్ చేశారు ఉషా మేడం లేదా అవి కూడా పెట్టాను ఇందులోంచి ముందు పీపీటీలు చూడు క్వశ్చన్ మార్దాం వద్దన్నది ఇంకొద్దులే ఇంకా సార్ అశోక్ సార్ సార్ అశోక్ సార్ సార్ అశోక్ సార్ సార్ ప్లీజ్ అన్మ్యూట్ సార్ అన్మ్యూట్ ఆడియో సార్
Original first partition again, showing scalable speedups for LS time 8,000 clusters. The third example I want to show you is our work on ANSYS Discovery, which is a summary. We are using parallelism across all forms, across all our solvers. Just to give you an example, our Fluent software is the most commercial grade CFD software, one of the most high performance software out there. And what this is showing is how we are able to use domain decomposition to break up a fluids problem into different domains. As a fluid is flowing from the left-hand side to the right-hand side, and we break it up into different domains. Each of those domains are sent to different processor clusters, and their processors share information across using API. Within each domain, we are using a shared memory parallelism, and then within that, we are using also GPU-based parallelism. So, result of this is Fluent runs scalably across 200,000 cores on both on-premise HPC as well as the cloud such as Rescale. So that's the first example. Second example is that of LS-DYNA. This is our premier crash simulation software. And so what this is showing is using explicit methods, and this is showing how LS-DYNA scales using a Rolls-Royce engine model as a representative model and running on a Cray machine on an Oak Ridge National Lab, the Titan machine. And this is showing a problem. The engine model has more than 200 million points. And what this is showing is how this is provided scalable speedups going from 512 NPI ranks clusters to 8,000 clusters. And in each cluster, we are running sort of a shared memory parallelism with 8 threads per rank. So this is a combination of NPI and shared memory parallelism. And the different curves are showing different types of partitioning that we have used. The next partitioning, the main card partitioning, and the original first partition. Again, showing scalable speedups for LS-DYNA up to 8,000 clusters. The third example I want to show you is our work on ANSYS Discovery, which is a software that has been written from scratch to take advantage of fine-grained parallelism on the GPUs. And we have taken the structural physics, the modal physics, the thermal physics, the electrothermal, and essentially getting it to run scalably on lots and lots of threads of a GPU. And this is showing it allows us to get instantaneous simulation as you are entering a new CAD design on a CAD tool. It gives you instantaneous simulation about the design changes. Now we took that core solver from the fluid solver from Discovery, and we have recently this year integrated that into a work on a multi-physics fluid solver, which is Fluent. And so essentially, in the Fluent example, I showed you how we are using domain decomposition to take a partition, to take a problem and break it into different partitions, and have each partition go into a processor. What this is with the same approach, but it's going to each of those regions going into a GPU. So it is a multi-GPU implementation, leveraging the fluid solvers in the Discovery software. So the results on the right are showing how this multi-GPU solver is showing speedups of up to 32 times using an 8-GPU NVIDIA A100 card. So this concludes our quick review of HPC. Now let me kind of focus on the use of AI machine learning on simulation. Now, when we look at AI/ML, we kind of look at sort of two broad approaches. One is a top-down approach where we use the solvers as a black box and an optimization platform such as OptiSlang, where you're using maybe 1,000 different runs to run a particular design, right, to 1,000 different variants. And typically each run would take maybe 100 hours. So the whole runtime would take 100,000 hours. What we are doing with the AI/ML is to take the first 100 runs of the design of experiments and use it to train the AI/ML models. In the remaining 900 runs, you are using the neural network-based fast algorithm. And so what this is showing is how we have combined OptiSlang with the AICTE solver for thermal modeling to get a thermal meta modeling which runs hundreds of times faster. We have combined, the bottom left is showing how OptiSlang has been combined with RedOptiC, which is a power integrity tool for power integrity meta modeling. And then the bottom right is showing how we have combined it with HFSS to do electromagnetics metamorphy. While these top-down methods work well for the specific use case that you're doing the design of experiments for, if you're trying to do a general purpose fluids problem, then you have to use a bottom-up method. And what this slide is showing is our ML solver for partial differential equations, for the fluids equations, for Navier-Stokes equations. And this is showing how you take a problem and you break it up into an 8 by 8 by 8 or a 16 by 16 by 16 region, and for that region, you try to solve the fluids problems. Based on the fluids problems, you try to train the neural network. So that's sort of what you're doing with the encoding. You're taking a higher dimensional problem, mapping it into a lower dimensional solution, using that to learn what is in the fluids physics, what's in the Navier-Stokes equations. And then essentially you can take that and essentially just like normal iterative methods, you sort of take the single solution path and you move it across to right hand side, and you build up a whole solution. So this basic idea of a ML-based solver was initially done for steady state solutions, then for transient solutions, then for regular meshes, irregular meshes. And the picture on the top right is showing how we have solved the external flow use case for an airflow over a car, and you have integrated with Fluent, and this gets a speed of about 100 times more than with the Fluent for the same accuracy. So very, very exciting work on bottom-up methods. The same bottom-up method we have applied to solving electronic chip package simulation problems. And what this is showing is when you have a large chip, maybe 1 billion transistors in the chip running at 2 gigahertz, it generates hotspots in the chip. And so typically, and then you have to, in order to do the chip thermal and the cooling of the chip, you have to use or ANSYS mechanical tools working with the Red Hawk SC and then doing the ICE-PACT through the whole fluid flow, the air cooling and the water cooling. Approach is to train and ICE-PACT models, right? Using it in the neural network approach, it runs much faster, 100x faster. We have also used this ML-based method for hotspot detection to, as we are showing here, like for the 10 by 10 micron region or 100 by 100 micron region, the run times go from 4.5 hours to 9 minutes. So very, very exciting work on, again, a bottom-up method for chip thermal. The third example I'm going to give is the first simulation job to a cloud. Customers are interested how much runtime will I need, how much memory will I need, because obviously the customers don't want to be surprised with the runtimes and the memory requirements on simulation. Now it turns out this is a very, very hard thing to predict, right? When you're submitting a mechanical and structural simulation job on the cloud, right? You can do it based on the size of the unknowns, right? So is it 100 million mesh points or 10 million mesh points or 100 or 1,000 million mesh points, right? That's one of the things. The other things are the actual finite element method FEM features, right? So essentially we have done a lot of work on data cleansing, data balancing, looking at through our ANSYS product information program, AP, we can collect a lot of data on this on our solvers running on-premise or on the cloud, and essentially using that we are training these neural network models, and based on it we have been able to we have launched just a mechanical resource prediction feature this year, and essentially what the results are showing is our memory prediction is showing is we are providing these Python interfaces to allow developers, engineers and professionals to build personal solutions, ATC licenses to our solvers like Mechanical or LS-DYNA or Fluent, and run it on their favorite cloud, be it Amazon, which is what we have got it working. In fact, this month we got it running with the Amazon marketplace for the cloud, and we will have future versions of this with other cloud partners. The right-hand side is showing is how we are moving towards, since we acquired OnScale, we now have the capability for a full SaaS-based cloud offering, a cloud-native offering to each of our solvers or mechanical fluids, HFSS, and running them on a SaaS-based manner, right? Based on servers and running it on a cloud in the by ANSYS platform, which is an open platform, does is to allow our customers, where people are moving away from hardware prototyping and testing to software prototyping and validations and virtual validation. It's enabled through simulation running on the cloud. So simulation allows customers to grow both top line revenue and bottom line savings. It allows a couple of areas of our long-term technology strategy. One around HPC.
Now, this PPT are visible?
Sir, visible, sir, visible. Thank you, sir. Good case study. Yes.
Intentionally, I have shown you this video so that we should know what is, because this is the study of one executive of Ansys cloud provider, and they have demonstrated what is their company, who are their customers, what technology is going on, how AI/ML is taking place today. So context. Hence, I have intentionally searched that and I have shown you, shared you, so that because when we are seeing any movie or any picture with our eyes, then it gets permanent memory in our minds. Hence, I have shown you to probably it will be remembering to you, and you will be knowing how it is going on. Means, of course, majority of these participants are not from IT or computer background. These are diverse, even from science discipline or other. Of course, all are from AICTE institutions, but not all IT or computer background or electronics background. Some are also from diverse faculties, diverse disciplines. Hence, they might be, technology terms, they might be finding somewhat difficult words. But with the help of this video, you might have got the clarifications, ki what is the meaning of this, or how this means hyper performance computing and cloud services are going on, and how it is affecting us. Of course, we are using this day by day. Daily, we are using our Gmail account. It is also one of the sort of this cloud services by Gmail, Google. Of course, they are providing some limited data. Now, this we go in our in other slides. Now, these are the key innovations shaping the future of HPC. These developments are in AI, GPU, cloud computing, and quantum computing. These technologies are enhancing HPC capabilities and expanding their accessibility and impact. Even in training large language models, LLMs, and performing inference tasks, each of these workloads have unique latency and performance requirements. Even core scientists' ability to rapidly deliver high power infrastructure helps business efficiently harness AI-driven workloads. Even these are different industry applications and beneficiaries in which we are finding this healthcare, finance, research, where computational power is essential to solving these complex problems. In this healthcare, this is means drug delivery, drug discovery, new methods of the drug delivery are also now made with the help of this AI and ML. And how this will be means effective, most effective, and in minimum time it should be absorbed in body. These developments are going on with the help of AI and ML in pharmaceutical industry. In finance also, this HPC supports risk analysis, fraud detection, and algorithmic trading, giving institution competitive edge. Then this, yes. Then this is HPC for finance. This is companies can respond quickly and more accurately to changes in market and finance. That's the example of this stock market. This resilience, it makes creating large system snapshots, planning redundancies, and having rapid recovery plans. These analytics can provide decision makers in financial firm far outweight the capabilities of human. Then manufacturing also we are using in supply chain logistics, process optimization. Large supply chains with thousands of stakeholders we are using, and with the help of these AI softwares, engineers and operators can minimize, optimize these processes, and minimum means downtime, the minimum maintenance, and makes a minimum waste also, streamlining operation and reducing cost too. And this predictive maintenance also, such complex system will also involve maintenance, which is this maintenance means downtime and loss of money and time. Hence, with the help of this digital team simulations and edge computing, we can engineers can prevent downtime by predicting failures or keeping regular maintenance schedules. Then genomic sequencing. This is a new area in which these DNA sequences are going on. Yes, it is shown now. Yes. Slide is visible, no?
Genomic sequencing is visible, sir. Visible.
Yes, yes. This slide, I am at this slide. Now, this is one of the most complex and resource-intensive problem in computing, and figuring this DNA sequence in organism is difficult, and moreover, it is more time-consuming. Even now, eliminating genetic disease and developing vaccines are even more now possible with the help of this high-performance computing and AI and machine algorithms. This is process acceleration in which this data and then in oil and gas applications also high performance computing is also means used on massive scale. This ONG sector is multi-billion-dollar industry that spends gas stations, oil wells, deep water platforms, thousands of miles of pipelines and storage facilities. With HPC, these companies and industry as a whole have approached the new approach for supply chain. This AI-driven AI analytics cut down on waste, they optimize designs per pipeline and trucking logistics and minimize the environmental impact also. So here this environment consideration, these have significant footprint, but looking for ways to cut that impact with the optimizing truck routing, migration to energy efficient machinery and more approximately manage oil and gas pipelines. This R&D work is going on. And these are these real world applications of AI in HPC. These institutes for data science focus on several key research areas including big data analytics, that is developing systems and tools for handling massive data sets, cyber security, creating technologies for encryption, privacy and information assurance. Then medical informatics, collaboration with national institutes to advance healthcare analytics, fintech, analyzing data for financial services and insurance companies, AI research focusing on machine learning and AI technology with industrial partnerships. This impact of large language models, LLMs. This LLM like GPT-4 and others are at forefront of AI research. These models trained on massive supercomputers possess parameters in trillions, enabling them to perform tasks approaching human capabilities. They can understand and generate natural language, create applications and perform complex reasoning. These implications for business. This AI can streamline hiring process, enhance customer interaction and drive innovation. This graph data science, a new frontier, that is this expert in this data quadrant, that experts introduce this concept of data quadrant, categorizing data problems based on known and unknown patterns. These known and unknown patterns, this solved using relational database, known objects and unknown patterns, this addressed by vertical database, known unknown objects and known patterns, this tackled with subgraph isomorphism and motive finding, and unknown objects and patterns, this most challenging and requiring graph data science here. This graph data science combines vertices, objects and edges relationships in a graph, enabling the analysis of large dynamic data sets. This includes applications in healthcare, in which modeling disease spread and understanding the clinical data, cyber security, detecting inside threats and cyber attacks, social networks, analyzing community formation and change, transportation, it is planning resource for emergencies. Then advanced intelligence, AI intelligence and graph analytics. The RH project, this framework, this is supported by national boundaries. The Archer project is open source framework for interactive property graphs. At scale, it integrates Python with high-performance programming language, enabling users to handle large-scale graph analytics seamlessly. And this combining productivity and performance. This framework allows users to interact with their data through notebooks while heavy computational tasks run on server. These are different real-world examples, applications of AICTE. In this healthcare, this AICTE models disease outbreaks and performs community detection in clinical data. During this COVID-19 pandemic, this helped in contact tracing by analyzing large data sets to identify potential transmission chains and inform public health strategies. Cybersecurity, this processes data to detect and attribute cyber attacks. And neuroscience, this is one of these groundbreaking application of RSNA in neuroscience, particularly in Connect Connectome project. These researchers can gain unprecedented insights into brain function, development, and disease by mapping neurons and their connections in various organisms' brains. This future of AI and HPC, this ongoing research and development, then massive graph analytics, developing algorithm tools for large scale graph analysis, then enhancing machine learning models, this creating more efficient, powerful AI models inspired by biological systems, real-time data processing, improving the capability to handle and analyze streamlined data in real time. This having educational impact, these institutions integrating AI and HPC are also finding their curriculum ensures the students are well prepared for the future job market, because nowadays we are finding these companies, they are also even these students, those who are having arts and commerce background, they are also now using AI and ML algorithms and models. It is not essential that only computer and IT or electronics people will use this AI and ML. Arts, commerce, science graduate, management graduates are using now this AI and ML models, because this is so means just it is the skill which is required at this stage in working this. Even IITs now have changed their entry qualifications parameters. Since last 2 years, up till now, only science, 11th and 12th science students were permitted to enter in BTech in engineering course or technology courses. But since last 2 years, now IITs and NITs, they have made arts and commerce students entry at 11th and 12th, and they can enter in first year BTech or B degree in IITs and NITs. Of course, they have to clear one or two more additional subjects in first year and second year. But at least arts and commerce graduates, they are finding their ways in technology fronts. So hence this offering these cutting edge programs and involving students in ground research, this next generation of AI and HPC is proving very useful in education sector also. This AI in everyday applications we are finding in day to day, even in our education sector, majority of our activities are now we are using generative AI models now. Even one case of copying case was heard in Punjab and Haryana High Court, in which one law student, he has submitted his assignments by using generative AI, and he has submitted all assignments, and the teacher who was assessing that assignments, and he has told him that it is copying material, and he failed him. This case gone to Punjab and Haryana High Court, and at that time Punjab and Haryana High Court judges, honorable judges, they were saying ki, and they given the clean sheet to that student. The reason ki at present this generative AI is not in the ordinances of our unfair means or copying materials, because it is not written anywhere ki this is coming under unfair means or copying material. Hence that law student, because of course here law student was so sharp, and I am telling you students are sharper than us. And this law student, he has used this generative AI for submission of his assignments. Of course, we are not advocating for this sort of technology used for this unfair means, but to the students they are using, means imagine how students are using this technology. Of course, we should encourage the students to use their brains and minds or take some sincere efforts, because when students are entering in education or university, at least they should be sincere in that. They should not go to these shortcuts. But anyhow, even then ethical considerations in AI are also there, in which this data privacy, algorithm bias, and transparency of AI decision making, These need addressing to ensure that AI techniques are used responsibly and ethically. Then collaborative research and industry partnerships. These industries are having some collaborations, partnerships are also there going on. So these are diverse sector in which this healthcare we are seeing the different cases. Finance also we are finding that transportation, supply chain management also navigating the means the vehicles is also one of these applications. Environmental sustainability in which climate data are climate conditioning and awareing natural disasters or weather forecast, weather patterns is also used here. Then these are AI and HPC in diverse sectors in which is healthcare, finance, environmental, transportation. These are the main four broad areas where AI and HPC are jointly working and benefiting these four sectors. Highest beneficial. Yes, yes. Within 2 minutes, I will wind. I am on last two, three slides. Then this is bridging the gap between AI research and practical implementation. Here we translate research into practice. Here real world case studies are there. Smart cities in which these AI and HPC are optimizing urban infrastructure, in which we are managing this traffic flow, reducing congestion and improving air quality also. These systems analyze data from various sources such as traffic maps, cameras, and sensors to provide real-time insights and solutions. Then personalized education also. Then precision agriculture is also there. These AI models. Yes, sir. Any questions or any suggestions?
No, sir. No, sir.
Okay, okay, okay. Then in precision agriculture also we are using this AI and HPC jointly. In which these AI models analyze soil sensors, weather forecast, and satellite imagery data to optimize irrigation, fertilization, and pest control.
Ashok, sir.
This,
Ashok, sir.
yes,
Sir, time is reached, and please conclude, sir. Conclude, and other sessions
yes.
will start on the WebEx.
Okay.
Yes, sir.
Yes, 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 yes. These are future trends, quantum computing, edge computing, which we have seen earlier. These are last slide I'm giving, that quantum computing, edge computing, explainable AI, and integration with IoT. Yes, from my side it is okay. Now, if any questions are there, welcome.
Sir, audience, please post your questions directly ask the sir.
So I
Many
have,
questions are asking in our sessions.
yes, sir, I have tried to fulfill or cover the contents of cloud computing
Yes,
in
sir.
this also.
Yes, sir. Yes, sir. Yes, sir.
Yes.
Your presentation is very nice and excellent, sir. Yesterday we are unfortunate to have a very good session.
No problem,
Thank
but
you,
we
sir.
have compensated that.
Yes,
I
sir.
have covered with, of course, slight more speed.
Yes, sir.
Since our topic is HPC, hence I also speeded in this.
Yes, sir. Yes, sir. Thank you very
Yes,
much for your kind support and collaborate with us with this ATAL FDP. On behalf
yes,
of our ATAL FDP, all the stakeholders and Bon Venkatchalmaya Institute of Technology and Science, Amlapuram, we are thankful to you. Thank you very much, sir. And we will conclude this session. Thank you, sir.
yes,
Thank you very much.
yes.
I
Thank you, sir.
request all the participants submit your feedback at 12th session, migrate to a WebEx session.